Today, I want to introduce you to L'Hopital's rule. So what is L'Hopital's rule? Well, if we have a limit, right, let's say we want to calculate the limit as x approaches 2 of x squared minus 4 over x minus 2, right? How would we calculate that? Well, in the past, right, we've calculated it by saying, okay, well, this equals the limit as x approaches 2 of x plus 2 times x minus 2 over x minus 2, right? And then we would cancel this out, and we would say, okay, well, then this equals 4, right? But L'Hopital's rule proposes an alternative to doing that. It makes it a lot easier, and especially when we start getting to more complicated limits, you're going to need it, right? So let's say we're trying to solve that same limit, but let's do it with L'Hopital's rule, right? Well, L'Hopital's rule tells us that if we plug in this number, right, in our case 2, to this, and we get either 0 over 0 or infinity over infinity, we can then take the derivative of the numerator over the derivative of the denominator, right, and still have that limit, and they will still be equal to each other, right? So let's try that out. Well, if we plug in 2, we get 0 over 0, so we can use L'Hopital's rule. So let's take the derivative of the numerator. The derivative of the numerator will be 2x. Then the derivative of the denominator, right, that's just 1. So then we plug in 2, and we get 4. So as we can see, that was a lot easier to do, right? So let's erase this, and let's look at a little bit trickier. Well, let's progressively get a little trickier through this video. Let's look at a trigonometric example. Let's say we have the limit as x approaches 0 of sine 5x over x. And let's solve it normally, and then we'll solve it with L'Hopital's rule and make sure our answers are the same, right? Well, this equals the limit as x approaches 0 of 5 times sine 5x over 5x. Right? And then you plug in 0 for this, and then as we know from this is a special, we have a rule for this, right? And this will be 1, so 5 times 1, that's 5, right? But now, let's try with L'Hopital's rule. So we plug this in, and we can in fact see sine of 0 is 0, x is 0, so we have 0 over 0, so we can use L'Hopital's rule. So we get the limit as x approaches 0 of, well, the derivative of sine 5x is 5 cos 5x, right, over then 1, right? Then we plug in 0, and we just get 5 cosine of 0, which equals 5. So as we can see, that was a lot easier for us to do. So now let's look at another example. Let's look at the limit, and we'll just use L'Hopital's for this one. The limit as x approaches 0 of x squared over 1 minus cosine 3x, right? So how do we evaluate this? Well, once again, what we're going to do is we're going to take the derivative of the numerator and the derivative of the denominator. Do not use the quotient rule. I've already said that, but don't use the quotient rule. That trips a lot of people up. Sometimes they'll use the quotient rule for this, and they'll get the wrong answer. So this equals the limit as x approaches 0, right, of 2x over, well, this will go away, and what's the derivative of cosine 3x? Well, the derivative of cosine x is negative sine, but it's already negative, so this will become positive. So what do we have? We have 3 sine 3x. But we can plug 0 in now, and what do we see? Well, this is still 0, and sine of 0 is 0, so we still have 0 over 0, right? Now, you might just stop there and think, okay, well, then we're done. We should use something else. We can't use L'Hopital's rule, but you'd be wrong. We can still continue with L'Hopital's rule. It'll still be equal to this. So then, this equals the limit as x approaches 0 of, well, this is 2, right? Then the derivative of this, well, we'll take out the 3 and we'll make it negative. So it'll be negative 9 cos of 3x, right? Then, what can we do from here? Well, we can plug in 0, and we get negative 2 over 9. And that is our limit. And that's our answer. So as we can see from that example, right, and this is what I really want you to pay attention to before I conclude this video, is that with low P-Tall's rule, you need to persist. Sometimes there will be examples where it'll just keep expanding and you'll never reach an answer. But what you have to notice is we had sine here, right? And sometimes you might come across examples where it seems like you're just going to expand the problem the entire time and you're never going to see light at the end of the tunnel. But as we can see, the next time we differentiate this, we'll have cosine of 3x rather than sine of 3x, which when it approaches 0, it is in fact still, it's 1, not 0, right? So we could see there is some light at the end of the tunnel, and that's the kind of stuff you have to be vigilant for, all right? Thank you for watching my video. Let me know if I said anything wrong or if you have anything additional to add. Have a great day.